Hi, it's Professor Nelson with the Joy Design Department at FIT. Class continuing with the organic modeling tutorial. Last tutorial, once again, this is about organic modeling, doing the top and sides method. This is the top. Before I continue with the sides, I'm going to give this top some further three-dimensional form. Once again, going to grab points, moving them up and down. It's important that I don't use rotate. Now that's not going to mean a lot to you guys right now because I haven't used it in any other tutorial, but as you go forward in modeling, I could rotate these points to get a nice downward slope. But if I do that, I throw off all of the relationships from the top view. Everything has to just be moved in the z-axis. As long as you move in the z-axis, it will not show from the top. Okay? Every viewport, every C-plane has a direction where you can move and have it not show in that C-plane directly. So if you're looking down from the top, you can move up and down in the z-axis and have no problem. If you're in the front C-plane, you can actually move in the y-axis towards and away from yourself, and it won't be obvious. If you're in the right C-plane, you can move from back and forth from side to side towards and away from the right C-plane. Anytime you're moving towards or away from the C-plane, it's not visible in that orthographic view. It doesn't change the design. So in our case, it's very important we keep the design the same from the top. So any movement of the points has to be going towards or away from the top C-plane, which requires one of your vertical C-planes. I'm going to have this taper down. Easiest way to do that is to just grab a set of points, move them down a little bit, and then keep moving. I can actually repeat the distance because since the rows of points are fairly evenly spaced, if I just keep hitting enter to repeat the command, you can see Rhino remembers the last distance there. So if I hit enter, it'll just accept the last distance. Hold shift key to make sure I go straight downward, and I'm good to go. Once again, I'm going to try and keep the last row of points or so level because it'll make making my point a lot easier. Putting a point on the end a lot easier. So I've moved those points down. I'm going to take off from where that started to happen and move some points up. Actually, leave that row there. Same method I'm using, just hitting enter in the middle of the command to repeat the amount of lift that I get. And then take these 3 points, move them up so where they're almost as high as that last selection was, and then move them down from there. Each row until I come back in to contact with this. And it's really not that important. I mean, I'm just doing this as a demonstration for you to see what can be done. If I were making a piece, I would have a design in mind that would tell me exactly what I'm trying to do here. I don't have a design in front of me. I'm just exploring the technique, which is what I hope you will do after watching these videos, is come back in and explore what you can do with this on your own, or apply this technique in your floral pendants. Okay, so there we go. It swoops up and down. Okay, see if there's anything I find objectionable in this. Maybe a little bit more of a rise here. Important to make sure that shift key is held down and that I don't accidentally go side to side, or I'll change the top. Remember, I've told you in control point editing, it's important to continually rotate the model and look and see what you have. Okay, now I'm going to commence with the extruding the sides. I'm going to go back into top C-plane because extrusions are always perpendicular to the current C-plane. And I'll go ahead and extrude straight down from the two edges. And I'll give myself a good distance. I'm going to select all of this now and move it straight up in the front view until I have an overall thickness I like here. Okay. Now, as you know, in jewelry, usually you have a flat bottom to your piece. If you wanted this to stay as it is here, consistent, moving along, and actually I don't care for what's happening here, so I'm going to record history this time. I need the top C-plane active. Repeat the extrusion and repeat the move. Oh, can't move it or I'll break history. So, fine. I'm just going to turn on my control points. There is some awkwardness here along this edge that I don't care for. And since my history is active, I can adjust these, and the side panels, the side surfaces will update automatically, allowing me to see very clearly what I have. Okay. Now I'll move everything up. By the way, I apologize for this level of volume here. With this headphone set, I have to turn it up quite a bit for you to get good reading or registering on what I'm saying, but it makes the alarm sounds in Rhino extremely noisy. I apologize. Like I was saying, usually in jewelry we want it to be flat on the bottom. If you didn't want this flat on the bottom, you would simply loft these two, and that lofted surface will once again follow, because it came off of these edges, it will follow the same pattern. So I would be able to use this to model it however I wanted. So, for example, turn on my control points for my side surfaces. Grab these two rows, move them down a fair distance. Okay, and that will allow me and move the bottom up a fair distance. Now, when I match the edge of this surface, how much it matches, how much it affects the top, is going to depend on how much reinforcement I have in rows of points. I have quite a few rows going lengthwise. Remember, it's a third-degree surface. It's going to affect things 2 or 3 rows away. So I'm going to have effects all the way up to here. This row of points will actually be affected. So if I don't have enough detail in here, I'm going to have to add a knot of a row of points or two by inserting a knot. We'll check and see how it looks. Surface, edit tools, match this edge to this edge, and you can see how much it has rolled that over. I'm going to keep it to tangency for now. If I want it to be smoother, I'll use points to do it individually. I'm going to look and see how much that changed my detail here on top. It didn't. It only rolled the edge, which means I have enough points in there to hold it steady. If the groove here had changed, if anything important to me had changed, I would have come back in and inserted a row of knots close to the edge, or another one in here, just more information through this area so that Rhino couldn't influence the surface all the way to the middle. But I have enough in there. I knew I did. It's the principle I want you to understand. That if your inside moves on your surface, you need to put more control point rows in. Okay, same thing over here. Okay. Now, if I don't like what I'm seeing, for example, there's a bit of a corner here. If I want that to be less noticeable, I can grab the row of points, and I would do it symmetrically. Okay, so this is the row of points just above that seam line, and I would select the whole row going all the way down and move them up. And you can actually see how your cross-section changes to see if you're getting what you want. Okay, that'll give me a more rolled effect. Okay, if I don't want it to seem this flat, I want it to have a more dramatic roundness. Okay, then I would undo the match, turn back on the points on the side walls, grab those top rows and move them further down so that I have more of a distance that Rhino's pulling that down to match the top to the... You see that gives a much more dramatic fall off. It still shouldn't affect my center much. Yeah, see, it doesn't, because I have enough control point information inside. And then the same process, if I want to adjust that, I'll just grab the second row of points up, both sides, and move it to get a softer, rounder feeling. Okay, check the other side, and that's pretty good. All right, so that's how I would get the top to work. All right, if I wanted to have a bottom surface doing the same thing, it's the same idea. I would have to make sure that this surface has a row of points down the center. I'll turn on points to see if it does. It does. It has some point information down the center. If it didn't, then you need something in the middle to anchor it. I'm not going to sculpt the bottom, so just some information, any kind of control point information down the middle will be sufficient. I'm going to match here, and I'm going to match, here. And you'll see that quickly gave me a softness there around the bottom. Okay? And once again, if I want that softness to be more extreme, by the way, notice how the whole thing came up more shallow. Okay? First off, if I want that to be more rounded on the bottom, I need to do the same thing I did for the top. I need to grab these bottom rows of points and slide them farther up. Okay? If I don't want this to lift off the ground, I need to put more control point information in. And the way to do that is to insert a knot. So, control point, insert knot, and toggle the direction. And I'll just go ahead and keep it, let it keep being symmetrical. I'm just going to add 2 more rows of points in. That should work. Match surface. Match this edge to that edge. And you can see that this bottom is staying more fixed. If I look at it from this view, shade it, it does keep that same overall depth. Now, of course, I don't like the cross-section there. It's very much a trough. Alright? But to fix that, I'm going to do the same thing I did on top. Grab these secondary row of points, both sides. Oh, this surface has a different direction. In this surface, this button, the V direction, is what selects the lengthwise rows of points. I'll just pull that down until I get something I like. If I want more control than this, I will need to put more point information in than what I've got. More control points means more control. Okay, so if I wanted that insert knot, I would take off symmetrical this time and put one right in the middle. And then I would select these two rows of points, remembering that the U and V direction is swapped on this surface. And I could further refine the cross-section from there. Okay? Now I still would have a cap I need to put on these points, but for the body of the piece, that's complete. Okay? I'm going to copy this out and then undo. And go back to here. Paste it back in. Put that on another layer for us to look at later. Like I said, in Rhino, though, usually we want a flat bottom. If I want a flat bottom to this surface, it's very tedious to come in here and adjust all of those points. All I do is set my top C-plane, turn on the points, grab those two bottom rows, and project to C-plane. Which are our shortcuts. Remember, you can always get project to C-plane under transform menu, project to C-plane. But on our keyboard shortcuts, it's C-enter. Delete input is yes. And that will automatically project that whole bottom of the surface, of those two surfaces, up flat. And once we have that, we kept a copy, you'll recall, of the initial surface. We would have a choice of joining these together, or we would have a choice. I'll actually copy that, undo. Or we would have a choice of, once again, rounding the bottom. Turning on the points, grabbing the bottom rows, moving them up, till we have a sizable gap here. This surface is the twin of what this was originally. We're probably going to want to add a little more control in here, so we will insert a knot, symmetrically toggle the direction. You can just hit S, enter, for symmetrical, or you can click it up there. Somewhere on both sides of the center is fine, just so we have some better control of the bottom here. and then match surfaces. And once again, grab the secondary row here and pull down. Nice and flat, and yet rounded on the bottom. So if you wanted to then flow this or do anything else with it, you could. So we have these three. I'll E-map them. Here we have one where the top and bottom both undulate together. Here we have one that comes flat to the C-plane. Here we have one that comes flat to the C-plane but is rounded on the bottom. Any one of those three options is fairly easy to do and have a lot of freedom and control as far as the form on top. Once again, if the sidewall here is something that you do not care for, if you don't want a sidewall, okay, for this piece it would be a challenge because it's flat bottomed. You're going to have a bit of a sidewall. Obviously for either one of these, let's take this one for example. It's a bit of a challenge because we're so close here. But I will explode it. Take my two side surfaces. The key here would be to adjust those control points to get them as close together as possible. So, turn on my points. I can't do much here, okay? But here I can. Gumball can come in handy here. If you push up on the, I got grid snap on. Make sure you don't have that turned on. On the bottom box, I'm going to non-uniform scale in the Z direction. Okay, that's probably going to be challenging here, but we can try it. Yes, it'll still work. So we could narrow. Be careful, because as you adjust this one, it affects these as well. And you can see we got a twist. Don't do that. Actually, the twist took place there. You can't scale one in front farther than the one behind, or it'll flip it'll twist the surface around itself. One thing you can do is just come here to the middle. Grab your big blocky ones and take them down to a reasonable level. And then And you do want to be as sensitive about this as you reasonably can. I'm on a video and you're spending your evening watching me, so I'm not going to go crazy with it. But it will affect the cross sections, of course, of the top surface. The farther down they go, the more rounded they become. So you at least want to have a certain amount of smoothness in these transitions. And it is good to just kind of be brief and quick about it. And then you can go in and fine tune it. But you get the idea. You can't go ahead and do the whole thing at once because different parts of the piece have different demands. As you recall, at the other end there we had almost no flat to even begin with. But yeah, if you come in and are sensitive, about catching it up. Alright, for our purposes class, I call that good enough. Okay, yeah, fine. I can come back now and rematch my surfaces. And you'll see it doesn't change much up in here. It'll change it a little bit, but not a lot. Match. 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 If I want to change the cross sections, I can do further control point editing, but that is about as rolled off as I can get. So there's almost no sidewall left on this piece. Okay? On the flat bottomed one, which is the more typical scenario, the same thing applies. The only difference here is that you are going to bring the, only one side of the surface down. First thing I would do if I wanted it fairly rounded all the way down is I would select those two rows and bring them, need a vertical sequence, bring them down further, and then now I do have a way of making this consistent all the way down. That would be to go to top C-plane, draw a circle. You've seen this in other tutorials. Set a C-plane to that circle, grab the top two rows of points, and project them to C-plane, deleting the original. That gives you a static height all the way down, and match surface. In this case, I don't care for some of what happened to the cross section there, so I would need to modify modify, and usually it's that second row of points that needs to be fine-tuned. But that's fine. You can, of course, fine-tune each one of these cross-sections individually if you want to. That's certainly possible. But yeah. And that would give you the most rolled over effect that would be practical for a flat bottom piece. Okay? So, that's it for this video. Thanks for watching.